Hello students, Ms. Slyman here with the video for 6.3 notes. And this time I have a formula booklet in front of me, so it's going to be a lot easier, no flipping. So we can use the compound identities for double angle formulas. Double angle formulas are when we have twice an angle. And so sine 2a is the same as sine a plus a. So I know from my compound angle, sine a plus a is going to be sine a cos a plus cos a sine a, which is just 2 sine a cos a, because multiplication is commutative, so I can change the order of these things. So there's my double angle formula. Sine 2a is 2 sine a cos a. Cos 2a then, cos a plus cos a, that's going to be cos a minus cos b, sorry, not cos b, minus sine b sine b. My gosh, of course not b's, a's, because we only have a's. Okay, which turns into cos squared a minus sine squared a. And then I can change this also from this point to be only with cosines. So if I changed my sine to 1 minus cos, that's going to turn into cos squared a minus 1 minus cos squared a, which is of course 2 cos squared a minus 1. Or I could have changed my cosine into sine, so 1 minus sine squared a minus sine squared a, which is 1 minus 2 sine squared a. So if you look in your formula booklet, you'll notice that in the formula booklet, there's this version given, as well as this version and this version. But they all derive from this first start. Okay, tan of 2a, there's a 2 missing in there, tan of 2a is tan a plus a, which is going to be tan a plus tan a over 1 minus tan a, which turns into 2 tan a over 1 minus tan squared a. So there's the formula for tan 2a. And of course, you find all of these in your formula booklet. Okay, so let's see how we use these. Sine x is 3/5, cos x is negative 4/5. That means I'm looking in the second quadrant. Because if I think about the second quadrant, 1, 2, 3, 1, 2, 3, 4, up here. And that's going to have a length of 5. So I'll have a positive sine value, a negative cosine value, so it must be here. So sine 2x, we've just discovered that sine 2x is 2 sine a cos a, x. Well, we know that the sine x value is 3/5, the cos x value is negative 4/5, so that's going to turn into 12 negative 24 25ths, exactly. Cos 2x is cos squared x minus sine squared x, or you could use any of the other ones. I think this one, for this case, since we know cos and sine, was nice and easy. Negative 4/5 squared minus 3/5 squared. That's going to give us 16 25ths minus 9 25ths, which would be 7 25ths. check my math. And then tan of 2x is 2 tan. So in this case, our tan is 3, negative 4. So 2, negative 3/4 over 1 minus negative 3/4 squared. So this is going to give me, that cancels and makes it 2, negative 3/2 over 1 minus 9/16, 16/16 minus 9/16, 7/16. Multiply top bottom, that's negative 48 over multiply top bottom, 14, and then I could simplify again to say negative 24/7. So let's separate these out. There we go. All right, so anytime you're told in this sort of problem exact values, again, we're coming back to our right triangle and our cast. Okay, this type of problem, we're told now where our angle is. Again, we're second quadrant. Find cosine of 2x. So very, very similar. Now we know 13, 12. So that means that 13 squared minus 12 squared, I think that's going to end up being 25. 13 squared minus 12 squared is 25, so this side ends up being 5. And that's, of course, negative. So cos 2x is, actually, in this case, we didn't even need to finish our triangle because we could have said cos 2x is 1 minus 2 sine squared x. So we could have done it that way just using our sine value. So 1 minus 2, 12/13 squared. So now we just have some calculations, 144, 169, and then we can do our calculations ourselves, or we can use our calculator. So 169 minus 2 times 144, we're going to end up with negative 119 1/69. And you could have used any of the cosine formulas. In this case, knowing where it is isn't really going to affect us because all of the cosine formulas involve squaring. So even if I had used cos squared minus sine squared, I still would have squared that negative 5, so it doesn't matter. Okay, 1 minus cos 2x. In this case, I'm going to use, well, actually, I don't know which one I'm going to use because I know that sine 2x is 2 sine x cos x. So up top, I'll just start with my other way. Cos squared x minus sine squared x. And if I'm going to simplify it, then I'm going to want things to cancel. But really, I'm not going to have anything that cancels out because if I look at this as a difference of squares, I have cos x minus sine x times cos x plus sine x. Nothing cancels. If I have, oh, I forgot the 1. That's better. Geez, don't forget this 1. So I need to erase this all because this doesn't allow me to slide things over. Okay, so on the bottom I have 2 sine x cos x. Up top I have 1 minus cos squared x minus sine squared x. Okay, so when I distribute, I've got 1 minus cos squared x plus sine squared x. But this, the 1 minus cos squared x, is sine squared x. My denominator is the same, but now I'm going to change this to sine squared x. So then I have like terms that I can put together. 2 sine squared x over 2 sine x cos x. And now I have canceling that happens. Cancel off one of the sine squareds with that sine x down there. Cancel off the 2's. That leaves me with sine x over cos x, which is tan x. So that's a nice simplification. Okay, another case where we're solving. Often you have double angle identities hidden. So this is not even very well hidden. 4 is the same as 2 times 2. So I can write that as 2 times sine x cos x. But this is sine 2x. And we've got minus root 3 equals 0. So I'll add the root 3 to the other side. Divide by 2. So now I have sine 2x is equal to root 3 halves. I'm looking between negative 2 pi to 2 pi. I know that sine is going to be equal to root 3 halves when my angle is pi over 3. So 2x. Pi over 3 is in quadrant 1. 2 pi over 3 is the quadrant 2 value. And then I just keep adding and subtracting because now we're going negative as well. So adding and subtracting 2 pi to every answer. I know, of course, that 2 pi is the same as 6 pi over 3. So I'll start with the subtraction. Pi minus 6 pi over 3, that's negative 5 pi over 3. 2 pi over 3 minus 6 pi over 3, negative 4 pi over 3. I know that normally I would have 4 answers, but since I'm dividing by 2, I'm going to have 8 answers. So I'm going to add 2 pi to both of those and get 7 pi over 3 and 9 pi over 3. That doesn't make sense. 8 pi, let's try. 8 pi over 3. Also, I'm going to add 2 pi once more to this one because I know I'm dividing by 2 pi. So when I add another 2 pi to that one, then I'm going to end up with 13 pi over 3. And I'm also going to subtract another 2 pi from this one because I'm going to end up dividing by that 2. So that's going to give me negative 10 pi over 3. Now when I divide everything by 2, I'm going to end up with all of these over 6. So 13 pi over 6, actually that's still going to be too big. That's going to be out of my range. But negative 10 pi over 6 is still within my range. 1, 2, 3, 4, 5, 6, 7. I should have one more answer. So I don't know if I have another negative one. Let's see, if I added another 2 pi, yes. So I have another negative 1 because when I add another 2 pi to this, that's going to give me negative 11 pi over 3. So when I divide by 2, I'll still be within my range of negative 2 pi to 2 pi. So we're going to divide everything by 2. That changes all of these denominators to 6. And like we said, this one is now out of our domain, but all of the rest are in, and I have 8 answers like I thought that I would. So x can take any of those 8 angle values. If I think about it graphically, sine 2x means my period has shrunk. So I have my graph happening. If I'm going from 0 to 2 pi, then sine goes, so now this is going to be 2 pi because my period has become pi. So I've got 1 period at pi, 2 periods at 2 pi. Continuing on, and that is negative 2 pi. And notice if I've got root 3 over 2, which is what I was looking for, root 3 over 2 is around here, and that's why I have 8 answers. Cos 2x plus cos x. I'm going to use the cos version, the cos 2x version that is only cosines. So that's 2 cos squared x minus 1 plus cos x equals 0. This is a quadratic. 2 cos squared x plus cos x minus 1 is 0. 2 cos x plus 1, cos x minus 1. Let's check and make sure. That's going to be negative 2 plus 1. That doesn't work. I need my sign switched, and I need to switch to the smaller eraser. So cos x, this one needs to be the minus, this one needs to be the plus. Okay, equals 0. That means cos x is a half, or cos x is negative 1. This is the easiest one to answer. That happens at pi. And if we're still going the same domain, that would be pi or negative pi. Cos x is a half. That happens at pi thirds, negative pi thirds, 5 pi thirds, negative 5 pi thirds. So there's all of my answers. And that's my last example. I will see you guys in class on Friday.